Picture this. Two doors. Behind one of them, something bad is definitely going to happen. Behind the other, something bad might happen, or might not. There's no way to know. Almost every person on Earth, when forced to choose, finds the second door harder to stand in front of. Not because the danger is greater, but because the mind doesn't know what to do with it. That instinct, that crawling, restless discomfort in the face of the unknown, isn't a personal flaw. It isn't weakness. It is one of the oldest and most deeply wired systems in the human brain. And understanding why it exists changes the way a person sees almost everything: anxiety, politics, horror movies, and the quiet dread that arrives at 3 in the morning for no clear reason at all. The story begins in a small, almond-shaped cluster of neurons buried deep in the brain, called the amygdala. The moment it detects something uncertain or threatening in the environment, it fires. It signals the hypothalamus, which immediately activates two powerful systems: the sympathetic nervous system and the adrenal cortical system. From there, the body floods with hormones. Adrenaline accelerates the heart rate and pushes blood toward the muscles. Cortisol raises blood pressure. Oxygen rushes to the brain. Blood glucose spikes to give the body a sudden burst of energy. All of this happens before the thinking mind has even had a chance to weigh in. There are actually two pathways the brain uses when processing a threat. The first is fast, almost instant. Information travels from the sensory thalamus directly to the amygdala, triggering an immediate response. The second pathway is slower. It runs from the thalamus up to the cortex, the outer layer of the brain responsible for reasoning and memory, where the threat is analyzed more carefully. The problem with the unknown is that this second pathway has almost nothing to work with. There's no threat to analyze, no outcome to predict, just open, empty possibility. And the brain, built for millions of years to survive, finds that emptiness more distressing than almost anything concrete. Researchers discovered just how profound this is through a study that has become one of the most cited in the psychology of stress. Participants played a computer game in which they overturned virtual rocks that might, or might not, be hiding snakes. If a snake appeared, they received a real, painful electric shock. The researchers carefully manipulated the odds and tracked stress responses through skin conductance, pupil dilation, and self-reported anxiety. The finding was striking. Stress didn't peak when participants were certain they'd be shocked. It peaked when uncertainty was at exactly 50%, when they had absolutely no idea what was coming. Uncertainty, in measurable, physiological terms, was more stressful than the guaranteed pain itself. This is not a glitch. It's a feature. Deep in the brain's architecture lies a structure called the striatum, shaped over several 100 million years of evolution. It doesn't just register rewards or punishments. It predicts the odds of them, and it becomes most urgently active when those odds hover near 50-50, because that is precisely when action is most needed. An animal that can predict a predator's behavior survives. An animal left guessing, with no pattern to read, is the most vulnerable of all. The brain that could not tolerate uncertainty was the brain that stayed alive. But that ancient machinery is still running in skulls that now navigate job interviews, medical diagnoses, and text messages left unread. And the mismatch is costly. Since the early 1990s, psychologists have identified a trait called intolerance of uncertainty, the degree to which a person is distressed by ambiguous situations. It exists on a spectrum. Most people score somewhere in the middle. But those who score high don't just find uncertainty unpleasant. It makes them stressed, irritable, and relentlessly motivated to eliminate it. Research by psychologists at Laval University in Quebec, who developed the Intolerance for Uncertainty scale, found that high intolerance is a common thread running through generalized anxiety disorder, excessive worry, depression, and substance use disorder. When the brain's warning system fires too easily and too often, it stops being protective and becomes the threat itself. The numbers make this concrete. In one study exploring how people handle uncertain waiting, only 37% of participants chose the objectively rational option, waiting a few seconds to find out a result. The rest were willing to accept a financial penalty just to know sooner, to escape the discomfort of not knowing, even when not knowing cost them nothing but a moment of suspense. The pull to resolve uncertainty is so powerful that it overrides logic, and it overrides more than logic. A 2014 study by researchers at the University of Virginia asked people to sit alone with their own thoughts for just 15 minutes. When given the option of delivering themselves a small electric shock to break the boredom and quiet uncertainty of their own minds, 2/3 of men and 1/4 of women chose to do exactly that. The empty, unstructured unknown of a silent room was genuinely harder to sit with than physical pain. This same machinery shapes entire societies. The philosopher and psychologist Erich Fromm wrote in 1941 that when people perceive disorder and uncertainty, the anxiety becomes so consuming that they will accept almost any leader who promises to replace the unknown with a clear, simple order. Decades of research have confirmed what Fromm observed. People who feel threatened want certainty, and they will trade extraordinary freedoms to get it. The brain that fears the unknown doesn't just flinch at dark hallways. It reshapes cultures. And yet, this is where it becomes genuinely strange. Human beings also seek out the unknown. They pay money to sit in dark theaters and feel their amygdalas fire. They ride into uncertainty voluntarily, gripping the safety bar of a roller coaster with sweating palms. Because when the threat is controlled, when the mind knows at some level that it is safe, the same cascade of adrenaline and cortisol transforms into something that feels almost like joy. The fear itself doesn't change, only the context does. The brain produces dopamine during staged fear experiences, turning the ancient survival alarm into something that feels, briefly, like a reward. The fear of the unknown is not a flaw to be fixed. It is the oldest conversation the brain knows how to have. A question asked by every nervous system that has ever tried to stay alive in a world that offers no guarantees. The unknown still sits behind that second door, and the brain, doing exactly what it was built to do, is still standing there, trying to decide. If this video made you think differently about fear, consider liking it and subscribing. There's much more worth exploring.